Hello, everyone. So in this session, we will be discussing recommender systems. And this is one of my favorite topics in data mining. So let's start with the overview. So what is recommender systems? Well, it utilizes various sources of data to infer customer interests. And we want to answer the question, what item should we recommend to a user? So some applications of recommender systems would be online streaming, such as Netflix, and online shopping, such as Lazada and Shopee. For social media, you have Facebook, Instagram, Twitter. And the techniques that we will be using for this course are the following. So we have content-based filtering and collaborative filtering. So there's memory-based and model-based. For the memory-based, you have user-based and item-based filtering, and for model-based, we will be using alternating least squares. So recommender systems are everywhere. When you use Netflix, there's recommender system in it. You want to recommend the videos or movies or shows that best match the user's interests. So what you're seeing right now is my feed on Netflix, because I'm into animes, I'm into dark shows, so that's what we're seeing here. You are also going to see recommender systems for dating apps. So the people that will be recommended to you would be those that are quite similar to you, depending on what algorithm it uses. But we'll be discussing those algorithms later on. So it's based on your interest, your profile, your age, your other features, your basically the things that you input in your profile. What else? You have Spotify, so it's for music. So same case, it is going to recommend songs based on your interests. And Google, of course, definitely, it's very popular. It's a recommender system. When you search for something, it recommends the best links for the search query that you have used. So as you can see, it's everywhere, and we will be tackling the techniques that are being used by these big tech companies. So what is recommendation? In a nutshell, it's basically this diagram that you're seeing here. So a user searches for a product or something, and then the system will recommend a product or an item or whatever it is that the user is searching for. That's the general idea. So the traditional approach for doing recommendation is that in the context of brick and mortar stores. So yeah, physical stores, and they have limited shelf space. So in the physical setup, we display the following. So you have hand-curated ones. So what could you do about that? You could just showcase the favorites, a list of favorites, or you could have the list of essential items, or you could simply base it on aggregates. So you could display the top 10 products, or the most popular, or the most recent. So that's how you go about it in a traditional setup. In a tailored approach, so this is something that you can see in an online setup. So you can tailor fit the items you show through recommendation engines. These engines are widely used by almost all big online platforms or services you can think of. Some popular examples are online shopping. Again, there's Amazon, Lazada, you have streaming, such as Netflix, Spotify. For search engines, you have Google, Bing, social media, Facebook, Instagram. Now, what's the difference of online and brick and mortar retail? So I'm going to be reading this excerpt from the book because I think it encapsulates the difference between the two approaches in recommendation. So an online retailer would use similarity measures for items to find pairs of items that, while they might not be bought by many customers, had a significant fraction of their customers in common. An online retailer could then advertise one item of the pair to the few customers who had bought the other item of the pair. This methodology makes no sense for a bricks and mortar retailer, because unless lots of people buy an item, it cannot be cost effective to advertise a sale on the item. Take note of that part. Thus, the recommender system techniques are not often useful for brick and mortar retailers. Conversely, the online retailer has little need for the association rule learning techniques, which we have used in the previous sessions. So those are frequent items of mining, all those things. Since those were designed to search for item sets that appear frequently, if the online retailer was limited to frequent item sets, they would miss all the opportunities that are present in the long tail to select advertisements for each customer individually. So again, this excerpt is from the Mining of Massive Datasets book, which is our main resource for this course. And the long tail phenomenon has been mentioned here. So what is the long tail phenomenon? The long tail is a term coined by Chris Anderson that describes the idea that the internet affects the types of products being sold that produce the majority of the revenue, such that selling a large amount of niche product is becoming more important to the sales of companies. And this visualization here shows that. So you have popularity in the y-axis and the products in the x-axis. So the items in the physical stores can only show the popular ones. But it's just a fraction of all the products that are out there. You could sell the remaining products in the online stores. So that's the long tail phenomenon, where it can only showcase this one in a traditional setup. But with the online one, we have access to everything. We could sell everything to the customer. I think this is just more examples of the long tail phenomenon. So this is different companies, and they're being compared to Walmart. The bar here that is very short, that's a Walmart. So the typical Walmart store has about this much songs as compared to Rhapsody. So Rhapsody is now known as Napster. So you can, if you have a bricks and mortar store, you can only sell that short bar here, this very small percentage of the products out there. Whereas if you have an online store, you could have access to all the products, all the songs. Same goes for Amazon. So in terms of books, you only have this much for a traditional physical store, but if it's online, you have this much for Netflix, same idea. And these pie charts here show the sales for those obscure items, the things that you can't find anywhere but online. So that's 22% of sales for Rhapsody, 57% of sales for Amazon, which is very big, and then 20% of sales for Netflix. So that's a long tail phenomenon. Now we have access to all those things that cannot be seen in the traditional store. Same is being emphasized here in this graph. So if you're just a physical retailer, you could only have access to this area here. But if you're a pure digital retailer, you could sell everything. Another example would be this. If you like Britney, you love Pink, No Doubt, and the Selector. Although only very few people are into the Selector, it might be something that you would like if you're into Britney Spears. This is something that you won't find if you're just in a traditional store, but it will be recommended to you if you use the tailored recommendation techniques that are present in the online setup. Now here's a very good story about the long tail phenomenon. So this is about the into thin air and touching the void. I'll be reading this excerpt from the book. So an extreme example of how the long tail, together with a well-designed recommendation system, can influence events in the story told by Chris Anderson about a book called Touching the Void. This mountain climbing book was not a big seller in its day, but many years after it was published, another book on the same topic called Into Thin Air was published. Amazon's recommendation system noticed a few people who bought who bought both books and started recommending Touching the Void to people who bought or were considering Into Thin Air. Had there been no online bookseller, Touching the Void might never have been seen by potential buyers. But in the online world, Touching the Void eventually became very popular in its own right. In fact, more so than Into Thin Air. So this is a very good example of the long tail phenomenon. If it weren't for the online setup, it won't be popular. So now finally, we have the following types of recommendations. Again, we have the hand-curated one and simple aggregates for the traditional setup, but you could also do the tailor-fit one that is tailored to the users. So here are the different approaches and recommendation. But first, we discuss a formal model. So we have to create a utility matrix. So first, we have the set of customers, which we call X, and the set of items, which we denote as S. And we create our utility function U. So it will be a matrix. It's X by S, so the customers by items. And it contains R, which is a set of ratings. R is totally ordered set. It could be from 0 to 5 stars, or it could be 0 or 1, just binary, depends. Basically, we have ratings in that utility matrix. So for example, we have this utility matrix here. Since I am into Genshin and into dark movies, that's what I have used here. So the users are mostly Genshin related characters, except Jude, because that's me. And items here are dark shows, dark and action ones, because there are action movies here as well. So the values here are the ratings. For example, Jude has rated 5 in Inception, 5 in Memento, 5 in Adventures, and 5 in the Matrix. Venti, 5 in Inception, none for Memento, 3 for Adventures, and then 5 in the Matrix. And you get the idea. So this is the utility matrix that we will be using a lot when we deal with recommender system techniques. We have to first come up with a way to turn our data into this utility matrix that we're seeing here. So what are some key problems? So first is gathering ratings. How do we collect the data in the utility matrix? And the other one is extrapolating unknown ratings. We are interested in identifying what the user likes based on his or her other preferences. So let's deep dive on the gathering ratings. So there are 2 ways to gather ratings. There's explicit and implicit. For explicit, we ask people to rate items. This is limited in effectiveness since users are generally unwilling to provide responses. For those who do provide responses, it may be biased to the people willing to provide ratings. With implicit, we learn ratings from users' actions. If the user purchases an item, we assume that, or visit the page, we assume that the user likes it, likes a product, or likes a particular page. But the problem with this is it cannot infer low ratings. It's just binary. That's the implicit approach. Okay, the next problem, extrapolating ratings. So utility matrix, it is very sparse for real world data sets, very, very sparse. Most users do not rate most items. So that's a problem, of course. And the other one is the cold start problem. First, new items have no ratings because we just started the system, the database. And new users have no history. So those are the problems. Okay, so here are the 2 approaches for recommender systems. First is the content-based, and the second is the collaborative filtering. So for content-based, we recommend items similar to previous items a user liked. But this system uses the properties or features of items to recommend to users based on their implicit or explicit ratings. The collaborative filtering, the general idea is we recommend items that are liked by similar users. This system focuses on the relationship of users and items. It recommends items to a user based on the items that other similar users like. So what are some other approaches that we could use? We could make use of a hybrid. So content based on collaborative filtering hybrid. So we use content based for a new item and user problem, then do collaborative filtering for the rest. This is what we do most of the time actually because of the cold start problem. At first, you have nothing. So use content-based approaches first while you're building that database. And once you have that, you transition to collaborative filtering once you have enough data points. Okay, other approaches, you could treat this as supervised machine learning problem. But this assumes that you also have lots of examples already. Okay, what else? You could also treat this as a clustering problem. You group similar items for users and recommend items accordingly. And that's it. Thank you.